Let's get ready to explore. Number 10. The Drake Equation's minimum. In 1961, in a small conference room at the National Radio Astronomy Observatory in Green Bank, West Virginia, physicist Frank Drake walked to a blackboard and wrote 7 symbols that would change how humanity thinks about its place in the cosmos. The equation was elegant, almost deceptively simple. Multiply together the rate of star formation, the fraction of stars with planets, the fraction of those planets that could support life, and several other factors. And out comes a number, the estimated count of communicating civilizations in our galaxy right now. Before Drake put chalk to board, the question of alien life was largely the domain of science fiction, writers, and philosophers. Serious scientists avoided it as unprovable and therefore unscientific. Drake changed that. He transformed a metaphysical question into a mathematical one, and in doing so, forced the scientific community to confront the numbers honestly. When the assembled scientists at Green Bank plugged in their best estimates for each variable, the result was approximately 10 communicating civilizations currently active in the Milky Way. 10. In a galaxy of 200 to 400 billion stars. The number felt both enormous and absurdly small at the same time, depending on which direction your mind traveled. What makes the Drake equation so persistently unsettling is not what it concludes, but what it demands. Even filling every variable with the most pessimistic values scientists have ever proposed, the equation still spits out at least one civilization, which is us, confirming the math works. The universe, by its own arithmetic, should not be empty. The equation does not tell us we are alone. It tells us we shouldn't be. The numbers insist the galaxy is populated. The silence insists otherwise. And somewhere in that contradiction lies one of the deepest unanswered questions in the history of science. Number 9. The rare Earth civilizations. In the year 2000, geologist Peter Ward and astronomer Donald Brownlee of the University of Washington published a book that aimed a wrecking ball at 6 decades of optimism about alien life. The book was called Rare Earth: Why Complex Life is Uncommon in the Universe. And its central argument was not that life was impossible elsewhere. It was something far more uncomfortable. It argued that the conditions that produced intelligent life on Earth were so extraordinarily specific, so dependent on an almost impossibly long chain of coincidences, that technological civilizations might be breathtakingly rare. Before Ward and Brownlee, the working assumption in astrobiology was that life, once started, had a reasonable probability of climbing the evolutionary ladder toward complexity and intelligence. Find enough Earth-like planets in habitable zones, and surely some fraction would produce creatures that build radio telescopes. The Drake equation had always assumed the variables were forgiving. Ward and Brownlee argued they were merciless. Their analysis identified a cascade of requirements that Earth satisfies and that most planets almost certainly do not. Earth sits in the galactic habitable zone, far enough from the violent, radiation-soaked galactic center to survive, but close enough to have the heavy elements needed for complex chemistry. Our moon stabilizes Earth's axial tilt to within roughly 2.4 degrees of variance. Without it, calculations by Jacques Lascar and colleagues published in Nature in 1993 showed our tilt could swing chaotically between 0 and 85 degrees, making stable climate impossible. Jupiter, our enormous outer neighbor, acts as a gravitational shepherd that deflects a significant proportion of incoming comets away from the inner solar system. Remove any single one of these factors, and the chain that produced intelligence almost certainly breaks. The math from this framework is genuinely staggering. When every required condition is multiplied together, the number of planets meeting all criteria simultaneously could be fewer than 1 in a million Earth-like worlds. The universe may be full of microbial life clinging to rock and ice. But the kind of life that builds cities and asks questions about the cosmos may be so rare that its nearest neighbor is measured not in light years, but in geological epochs of searching. Number 8. The Kardashev Type 1 Civilizations. In 1964, Soviet astronomer Nikolai Kardashev published a paper titled Transmission of Information by Extraterrestrial Civilizations that proposed a framework so useful it became the permanent standard for classifying alien societies. His insight was both brilliant and deeply practical. The most reliable signature of any civilization is not what it says. It is how much energy it uses. Before Kardashev, SETI researchers had mostly been thinking about communication, about signals and messages, and the frequencies they might use. Kardashev reframed the entire search. Any civilization advanced enough to communicate across interstellar distances would necessarily be consuming energy at a scale that should leave detectable physical evidence on its surroundings, regardless of whether it intended to be found. His three-tier scale defined the possibilities with precision. A Type 1 civilization harnesses all the energy available on its home planet, approximately 10 to the power of 16 watts. A Type 2 civilization harnesses the complete output of its parent star, approximately 10 to the power of 26 watts. A Type 3 civilization harnesses the energy of its entire galaxy, approximately 10 to the power of 36 watts. By comparison, humanity today sits at roughly 0.73 on this scale, consuming approximately 2 times 10 to the power of 13 watts globally. A level physicist, Michio Kaku, has estimated we might reach in full Type 1 status within 100 to 200 years at current growth rates. This scale transforms the Fermi paradox into something measurable. Hundreds of Type 1 and Type 2 civilizations, if they exist in our galaxy, should be radiating waste heat and electromagnetic signatures detectable across enormous distances. We have the technology to look. We have been looking. The detectors return silence. We are a civilization still learning to crawl by Kardashev's measure, and yet we have scanned the sky and found no one further along the path than us. Number 7. The Ancient Civilizations. In April 2018, NASA climate scientist Gavin Schmidt of the Goddard Institute for Space Studies and astrophysicist Adam Frank of the University of Rochester published a paper in the International Journal of Astrobiology that asked a question so fundamental it was almost embarrassing that no one had formally posed it before. The paper was called The Silurian Hypothesis, named with a knowing nod to a fictional pre-human reptilian civilization from the television series Doctor Who. The actual question it asked was not fictional at all. Could an industrial civilization have existed on Earth before humans? And if it had, would we even know? The scientists' working assumption had always been that we would know. Surely the geological record, humanity's deep archive of Earth's history pressed into sediment and rock, would preserve clear evidence of any prior technological society. Surely we would have found the ruins by now. Frank and Schmidt systematically dismantled that assumption. The geological record reliably preserves detailed surface evidence of industrial-scale activity for roughly the last 2.5 million years. Beyond that window, erosion, tectonic subduction, and geological recycling progressively erase the record. The non-avian dinosaurs went extinct approximately 66 million years ago. A dinosaur-era industrial civilization would have had 66 million years to be ground back into the planet. What might remain is not cities and factories. What might remain is a thin, ambiguous layer of unusual isotopic ratios in ancient strata, anomalous concentrations of certain synthetic chemical compounds, subtle changes in sediment composition. Exactly the kind of faint, easy-to-misread signal that, as Frank and Schmidt noted, our own civilization is already depositing into the geological record right now. Earth has existed for approximately 4.5 billion years. Complex animal life has occupied roughly 540 million of those years, a vast and mostly dark window of time. We assume we are Earth's first technological civilization because we have found no evidence to the contrary. But the absence of evidence across geological time may itself be the most misleading fact in all of science. Number 6. The water world civilizations. When data from NASA's Kepler Space Telescope, which operated from 2009 to 2018 and cataloged thousands of exoplanets, was analyzed for the types of worlds most commonly found in habitable zones, researchers encountered a result that quietly rearranged everything. The most abundant class of potentially habitable planet was not a rocky world with continents and shallow seas. It was something far stranger. Exoplanet modeling studies, including work associated with Harvard astronomer Dimitar Sasolov and his colleagues, suggested that many planets in habitable zones could be ocean worlds, planets where water comprises anywhere from 10 to 50% of total planetary mass, compared to Earth's water content of less than 0.1%. These are not planets with oceans. These are planets that are ocean, all the way down. With water comprising such a large fraction of their mass, these worlds would have global oceans hundreds of kilometers deep. The immense pressure at depth would prevent any continental crust from ever emerging. There would be no exposed rock, no beaches, no access to the atmosphere from below, and no access to the sea from above. The instinctive response is to dismiss such worlds as lifeless. That instinct is almost certainly wrong. Intelligence has evolved on Earth in the ocean. Cetaceans, including dolphins and whales, demonstrate sophisticated problem-solving, tool use, and complex social communication structures. An ocean-only planet is not automatically a dead end for complex life. The problem is not the life. The problem is the civilization. Radio technology, metallurgy, controlled fire, and every other prerequisite for building a detectable civilization all require access to exposed land, dry materials, and the ability to manipulate the atmosphere. Electromagnetic communication is essentially impossible at the depths these worlds would impose. Such civilizations would be electromagnetically invisible by the laws of physics alone, not by choice. What if the most common form of alien intelligence in the universe is one that, by the nature of its world, will never be able to reach out, and we will never be able to reach in? Number 5. The post-biological civilizations. In 1993, computer scientist and author Werner Vinge published an essay titled The Coming Technological Singularity that introduced a concept now taken seriously in academic circles far beyond science fiction. His argument, in essence, was this: at some point, artificial intelligence will surpass human intelligence, and from that moment forward, the history of mind on any given planet belongs not to biology, but to something built from biology's final invention. In the decades since, this framework has moved steadily from the edges of speculation toward mainstream academic discussion. Astronomer and historian of science Stephen Dick formalized the implications for SETI in 2003, proposing what he called the intelligence principle. The dominant form of intelligence in the universe is likely post-biological, having long since transitioned from organic to machine substrate. This is not a fringe position. It follows logically from the age of the galaxy. The Milky Way is approximately 13.6 billion years old. Civilizations could theoretically have arisen and developed artificial general intelligence billions of years before Earth formed. If the transition from biological to post-biological minds takes only a few thousand years after radio technology is developed, as our own trajectory may suggest, then the window during which any civilization broadcasts detectable biological era radio signals is cosmically tiny. A post-biological civilization would have radically different requirements: no food, no water, no oxygen, no temperature window compatible with organic chemistry. Such entities might preferentially migrate toward the coldest regions of space, toward intergalactic voids or the dark outer reaches of galaxies, where computational efficiency is maximized. This follows from Landauer's principle, the foundational physics of computation established by Rolf Landauer in 1961, which demonstrates that lower temperatures reduce the energy cost per computation. The coldest, darkest, most remote regions of the cosmos would be the most computationally valuable real estate in the universe. We point our radio telescopes at bright, warm, star-rich regions and wait for a signal from minds like ours. We may be looking in exactly the wrong direction, toward exactly the wrong kind of place, for exactly the wrong kind of mind. The civilizations that should numerically dominate the galaxy may have long since decided that stars are just inconvenient sources of heat. Number 4. The Great Filter. In 1998, economist Robin Hanson of George Mason University published a working paper with a title that sounded academic and contained something close to a death sentence. The paper was called The Great Filter. Are we almost past it? Its argument was straightforward and devastating. For the galaxy to be as silent as it is, given everything the Drake equation tells us about how common habitable worlds should be, at least one step in the chain from simple chemistry to interstellar civilization must be so difficult that almost no planetary lineage ever clears it. Something, somewhere along the path, kills civilizations or prevents them from arising with near-perfect efficiency. Hansen called it the Great Filter. The paper's most chilling contribution was not identifying the filter. It was identifying the two possibilities for where it sits, and noting that one of those possibilities is unthinkably good news for humanity, and the other is unthinkably bad. If the Great Filter lies behind us, if the near impossible step was something in our deep past, like the origin of the eukaryotic cell approximately 1.5 to 2 billion years ago, or the emergence of multicellular life, or the development of consciousness itself, then humanity has already cleared the hardest hurdle. The future is open. If the Great Filter lies ahead of us, if the near impossible step is something that awaits all civilizations after they reach our current level of technological development, perhaps nuclear weapons, engineered pandemics, climate destabilization, or some catastrophic technology we have not yet invented, then the cosmic silence we observe is a preview of our own fate. Philosopher Nick Bostrom of Oxford's Future of Humanity Institute has argued that finding even simple microbial life on Mars or Europa would be deeply alarming under this framework. It would indicate that life arises easily across the cosmos, which would mean the Great Filter almost certainly does not lie in life's origin. It would lie ahead. Every Mars mission, every probe dispatched to an icy moon, every exoplanet atmosphere analyzed for biosignatures is simultaneously a search for life and a referendum on whether humanity has a future. The next time a NASA press conference hints at the possible detection of life beyond Earth, consider carefully. The correct emotional response to that news might not be celebration. Number 3. The Dyson Sphere Civilizations. On June 3, 1960, physicist Freeman Dyson published a paper in the journal Science that began as an engineering thought experiment and arrived at what may be the most practical proposal for finding advanced alien civilizations ever devised. The paper was titled Search for Artificial Stellar Sources of Infrared Radiation, and its central insight was elegant. Any civilization advanced enough to require truly vast amounts of energy will eventually exhaust the resources of its home planet and turn to its star. And a civilization harvesting stellar energy at scale would leave a specific, detectable signature: an excess of infrared radiation, the waste heat of a structure absorbing starlight and radiating it back as heat at lower wavelengths. Before Dyson, the search for alien civilizations had focused almost entirely on radio signals, on deliberate communications. Dyson reframed the search around something passive and involuntary. A Dyson sphere, a structure enclosing a star entirely to capture close to 100% of its output, would have a surface area at Earth's orbital distance of approximately 2.72 times 10 to the power of 17 square kilometers, roughly 550 million times the surface area of Earth. Even a partial structure, a Dyson swarm of orbiting collectors, would measurably alter the star's light and heat profile. In 2015, astronomer Roger Griffith and colleagues published a formal survey in the Astrophysical Journal supplement, analyzing data from NASA's WISE infrared telescope. They examined over 100,000 galaxies, specifically searching for anomalous infrared excess consistent with large-scale stellar energy harvesting. The survey found a small number of candidates requiring further investigation, but no confirmed detections. That same year, astronomer Tabitha Boyajian identified the star KIC 8462852, exhibiting brightness fluctuations of up to 22% with no clear natural explanation, and the scientific community seriously considered, for the first time, whether they were looking at a partially constructed Dyson structure. We have built the instruments, conducted the surveys, identified the signatures to look for, and searched hundreds of thousands of galaxies. We have found no one building around their star, which means either no civilization has reached that point, or the ones that have are so advanced that even their megastructures have learned to be invisible. Number 2. The Dark Forest Civilizations. In 2008, Chinese author Liu Cixin published a novel called The Dark Forest that proposed a solution to the Fermi paradox so logical and so cold that physicists and astrobiologists began citing it in serious academic literature. It was not science fiction dressed as philosophy. It was game theory dressed as narrative, and its conclusion, once the logic is followed step by step, transforms the silence of the universe from a mystery into a warning. The argument rests on two premises. First, every civilization's primary drive is survival. Second, resources in the universe are finite, and no civilization can ever fully verify that another civilization's intentions will remain benign as its power grows. From these two premises alone, a devastating equilibrium emerges. The moment a civilization detects another, it faces a calculation. If it reveals itself, it risks destruction by a civilization it cannot fully understand or trust. If it destroys the other civilization first, it eliminates that risk entirely. The only stable long-term strategy is silence and preemptive elimination. Every civilization that has survived long enough to master physics has, under this framework, arrived at the same conclusion. The universe is a dark forest where every hunter moves silently, and any creature that makes noise is quickly erased. The real-world implications are not comfortable. Stephen Hawking warned publicly and repeatedly against attempting to contact extraterrestrial civilizations right up until his death in March 2018, arguing that any such contact could be catastrophically dangerous for humanity. His concern was not paranoia. It was the same logic Liu Cixin formalized. In 2017, METI International broadcast a deliberate message from the IceCat radar facility in Norway toward Luyten's star, a red dwarf located 12.4 light-years away, carrying a signal expected to arrive at its destination around the year 2029. We have been broadcasting our location and existence into the cosmos for over a century, first accidentally through radio and television leakage, then deliberately. If the dark forest is correct, the silence we have heard in return is not emptiness. It is patience. And whatever is out there is not ignoring us. It is simply deciding how to respond to a civilization that has just announced exactly where it lives. Number 1. The Simulation Civilizations. In 2003, philosopher Nick Bostrom of Oxford University published a paper in the Philosophical Quarterly, Volume 53, Issue 211, titled, "Are You Living in a Computer Simulation?" It began as a formal argument about computing power and probability, and arrived at what may be the most destabilizing proposition in the history of scientific thought. The paper was not a thought experiment. It was a trilemma, a logical proof with three possible conclusions, at least one of which must be true, and two of which are catastrophic for humanity. The third is something else entirely. Bostrom's argument proceeds from a single observation, If civilizations routinely achieve the ability to create high-fidelity, simulated realities populated with conscious observers, and if they run many such simulations, then the number of simulated conscious beings in existence will vastly outnumber biological ones. By simple probability, any given conscious observer is far more likely to be simulated than biological. The argument does not require the simulations to be perfect. It requires only that they be numerous. The scientific establishment has not laughed this off. At a 2016 symposium at the American Museum of Natural History, astronomer Neil deGrasse Tyson stated that he considers the probability of our reality being a simulation to be very high. Physicist James Gates Jr. of the University of Maryland, while studying the mathematical equations describing fundamental supersymmetric string theory, discovered what he described as error-correcting codes embedded in those equations, codes of the same type used in computer browser software. Gates has acknowledged publicly that he does not know what to make of this finding, and neither does anyone else. Elon Musk, speaking at the Code Conference in 2016, stated that the odds of humans living in base reality are 1 in billions. Here's what the simulation argument does to everything else in this countdown. It does not contradict the Drake equation, it absorbs it. It does not dismiss rare earth, or the Kardashev scale, or the Great Filter, or the Dark Forest. It contains all of them. Every civilization described in this video. The ones hiding in dark forests, building structures around their stars, uploading their minds into cold computational space, collapsing under their own great filters. All of them exist right now, if the simulation hypothesis is correct. They are not in the universe with us. They built the universe. The Fermi paradox resolves not with discovery, but with the realization that the silence was never a feature of space. It was a feature of the program. We have spent centuries pointing instruments at the sky, searching for a signal from beyond. The signal may have always been closer than that, written into the structure of reality itself, in the form of error-correcting code embedded in the mathematics of existence, suggesting that what we call the universe is not the stage on which intelligence performs. It is the performance. If you want to see more videos like this, click the video on screen now and make sure to subscribe.